Hello everyone. Now in the earlier video, I shared with you how we're going to use the barometer to determine the atmospheric pressure. For this video, we're going to explore what happens if we actually change the vertical height of the barometer. Now we're going to assume that this is atmospheric pressure that we're dealing with, and hence this value is 760 millimeters. So what happens if you slant the test tube until the vertical height becomes less than 760 mm? You realize that there's no more vacuum. Okay, there's no more vacuum, and hence the atmospheric pressure cannot be determined. So you got to raise the test tube until it's more than 760 mm. Then once you see a vacuum, once you see this vacuum, you will be able to determine the atmospheric pressure. The same goes for the next diagram, where you lower the test tube until it's fully submerged, until the vertical height is less than 760 mm. Sorry, I wrote wrongly. Should be less than 760 mm. And once it's less than 760 mm, there's no vacuum shown. The vertical height, the atmospheric pressure cannot be determined. Now, what is the purpose of lowering the tube until it's less than 760 mm? There's a reason for this. Because it doesn't serve any purpose when you cannot make any measurements out of it. Now, the primary purpose of lowering it to that is for you to determine if the space above mercury column contains air. Contains air or contains some form of vapor. Example, mercury vapor. If you leave the barometer long enough, some of the mercury will escape the surface and become mercury vapor. So you push the barometer down to less than 60 mm, and then from there we see whether is there a bubble. Okay, if there's a bubble when the vertical height is less than 760 mm, if a bubble appears at the top when the height is less than 760 mm, it means the space contains air or mercury vapor. What it means is that when you raise it back to the vertical height of 760 mm, you will not get atmospheric pressure. So that's all it says. That's all it does.